SOH CAH TOA. SOH CAH TOA. Okay, so again, I cannot spell that word for you come test time. You need to know how to spell that. So, SOH CAH TOA. What does SO stand for? Sine. Sine. The S stands for sine. O stands for opposite. H stands for hypotenuse. What does CAH stand for? Cosine equals adjacent over hypotenuse. So where did I leave off? That was cosine. So now let's do tangent. TOA. Tangent is equal to what? Opposite over adjacent. All right, so let's talk about a triangle. When you have specifically a right triangle, we're only using trigonometry in right triangles. Actually, that's not true. When we get back from spring break, we'll use non-right triangles. But when we have a right triangle, there are a couple things that I need to make sure that you know. First off, your right angle is always going to be called angle C. Okay? Your right angle is always going to be labeled angle C. The other two, I tend to put A at the top and B at the bottom, but it doesn't really matter. What really matters is that C is your right angle. Okay? Why is that important? Well, sometimes they're not going to have a picture for you, and you're going to have to come up with a picture. When you come up with a picture, you're going to have something like this. You label C as your right angle. A and B are the other two. Couple things you need to know. First off, capital letters mean angles. Did you catch that? Yep. Capital letters mean angles. Lowercase letters mean sides. Lowercase letters mean sides. So when you're asked to give me a capital B, your answer should have degrees next to it, because a capital letter means you're giving me an angle measure. If you're giving me a lowercase b, then you should have inches or feet or something, because you're giving me the side length. So how do I know what side is little b, what side is little a? We're always using A, B, C. And in this example, we're going to give these values here. We're going to call AC, right here, we're going to call that 3. BC we're going to call 4. And AB we're going to call 5. And I'm going to tell you which one's little a and which one's little b and which one's little c in a little bit. But right now we're just going to deal with that. Okay? And I'm going to answer these problems right here. If I am trying to find the sine, not sin. Please talk about sin in church, not here. Okay? That is sine of angle A. Here's angle A. Is equal to opposite over hypotenuse, correct? What side is opposite of angle A? Well, if I were to go completely straight out from that angle, what side is that? BC or CB, whatever, right? That's 4, correct? Good answer. Over the hypotenuse. Which one's the hypotenuse?
The one that says hypotenuse.
AB, the one that says hypotenuse, and that is 5 for our example. So far, so good?
Yes.
I actually find it easiest if you actually label right on the triangle. So I would say that's 5. Let's see, BC is 4, and that's 3. I find it easier just to pull it from there as opposed to looking at these segment lengths. What about cosine A? Cosine is adjacent over hypotenuse. So what side is adjacent to A? 3. Now just a little reminder, because some people get confused as to which one's adjacent. Adjacent is one of the two sides that actually makes the angle. The angle is always made up of two sides, one side there and one side here. One of those two sides is the hypotenuse, always, and the other one is what you're going to call your adjacent side. So my adjacent is 3 over my hypotenuse, which is 5, so my cosine of angle A is 3 over 5. What is my tangent of A? 3 over 4, are you sure?
4 over 3.
4 over 3. Why is it 4 over 3 and not 3 over 4? Opposite comes first, adjacent is on the bottom. Questions about that? That should be review from IM2, correct? Okay. Next thing I want to do is I want to take this, and if I know that the sine of angle A is 4/5, I need to find what the measure of angle A is. How do I do that? Well, I got to look for this thing on my calculator. That's called inverse sine, or sometimes it's called arc sine. The reason why I have arc sine listed there is because when you take your SBAC test and you use that Desmos calculator, they use the term arc sine as opposed to this sine -1 thing. So you got to be familiar with both. So I'm going to come here. If I press my sine button, do I have that -1 with it?
No.
No. So how do I get the -1? Because I see it right there. I have to press second or shift. Some calculators you use shift. And now do you see that -1 there?
Yeah.
Yep, that's what I'm looking for. What do I type in though? I want inverse sine of what? Type in what the sine value of that angle is. So 4 divided by 5. And that gives me 53.13. We're just going to round off to 1 digit past the decimal. So I'm going to call it 53.1 what? Degrees. Okay. Now, the next one, if I move on to this cosine one, this is exactly the same, right? The same angle, I should say. Still the same angle. We're still talking about angle A. We're just using cosine instead of sine. So if this is the same angle, shouldn't I get 53.1 degrees? Because it's still angle A. Well, angle A is still angle A. That hasn't changed. What's changed is whether I'm measuring the sine or the cosine. So if I use inverse cosine or arc cosine, and what am I going to type in? 3/5. I should get the exact same angle measure, do I?
Yeah.
Yep. And then finally, if I do tangent of A, that's still the same angle, isn't it?
Yep.
Let's do arc tangent or inverse tangent of 4/3, 53.1. And again, please label it with the degree symbol. So if I want to find the angle, I have to use that arc sine, arc cosine, or that -1 thing in your calculator. Okay? All right. Let me label these sides now. Okay? Here's how we get the little a, little b, little c that I said I'd come back to. Side little a is the opposite of angle A. So if this is angle A, the side opposite is little a. That would be the side that's labeled 4. Side little b is the side that is opposite angle B. So if this is angle B, little b is the side that's labeled 3. And that leaves the last side as side little c because it is opposite angle C. And if you remember from your Pythagorean theorem, a squared plus b squared equals c squared, c is always your hypotenuse. Okay? Kind of makes sense? So if I wanted to find the sine of angle B this time, if this is angle B, what is the side opposite? Give it to me as a letter. Little b over the hypotenuse is little c. What if I wanted to find cosine B? What's adjacent? Little a,
4.
right? Little a over the hypotenuse, which is c. And the tangent of B is opposite. What's opposite B? Little b. And adjacent? Little a. So that's how I would find those guys. Okay? And yes, you would go ahead and fill in the values. That would be 3/5. This would be, what, 4/5. And this one would be 3/4. Yes.
So for the adjacent, it's how do you know it's B? Or how do you know it's little a? Because isn't C also adjacent to angle?
C is adjacent, however, it's also the hypotenuse. So hypotenuse takes precedence. Hypotenuse has to be the one that's opposite your right angle. So once you label a hypotenuse first, really. and then the one that's next to it would be your adjacent. Okay. All right, so coming down here, if I wanted to look at a problem like this, let's see, find the missing side. So I need to find what side Y is. How would I find what side Y is? Well, I'm going to look at what they've given me. They've given me my right angle, they've given me another angle, and they've given me the hypotenuse. Now, I'm not going to use the right angle ever when I'm using SOH CAH TOA. I always have to use one of the acute angles. So they've given me this angle. How would you say Y is related to that angle? Is it opposite, adjacent, or hypotenuse? Opposite. And then they've also given me the 20. Is that then adjacent or hypotenuse? Hypotenuse. Remember, that one's got to be hypotenuse because it's across the right angle. The adjacent side would be this guy right here. Okay? So if they've given me opposite and hypotenuse, which one am I going to use? Sine, cosine, or tangent? Sine. So I'm going to set up a little equation that says sine of 55 degrees is equal to opposite over hypotenuse. You okay with that? How do you think I'm going to solve for Y? I got to get Y by itself. What should I do? Multiply by 20. That leaves me with, now I'm going to go straight to my calculator. Do I have to use the inverse sign thing, the -1? No, because I know what the angle is. So I just do 20 sine 55, and I get 16.38, which rounds off to 16.4, and I need to give it some kind of a label. Is it degrees? Is it, what is it? Feet. Right? Because that's the unit they're using, and I'm talking about a side length. Does that make sense? Okay. What about the one below it? They give me an angle, and this is labeled funky. It really should say N in the middle over here, not just on the left. A little spacing issue. But they give me the side over here labeled as 5 centimeters. Would you say that is opposite, adjacent, or hypotenuse? Opposite. That is opposite with regards to 30 degrees. Then they also have this N labeled. What is that side? That is hypotenuse. What uses opposite and hypotenuse? Sine. So if I set up my equation, this equation is slightly different. Sine of 30 degrees is equal to 5 over N. Why is this one slightly different? My variable is on the bottom. So that means I have one extra step in solving. So I'm still going to multiply both sides by that bottom number, which happens to be N in this case. And that freaks some people out because they're like, wait, you're not supposed to cancel out your variable, only the letter that's with it. Well, I canceled it out there, but it's reappearing over here. So I have N times sine of 30 degrees equals 5. Now how would I get N by itself?
Divide by sine of 30.
Divide by sine 30.
Miss Frankie,
Yes,
why does the variable go on the bottom for that one?
because it was the hypotenuse this time. Okay, so instead of doing something times sine, this time I'm doing 5 divided by sine of 30. What do I get? 10. So N is equal to 10 what? Centimeters. So? All right. Yep, this should be review from last year. Okay. What about this guy? Here's my angle. I have Z and I have 20. 20 is clearly what? Hypotenuse. What is Z with regards to 35? Adjacent. What uses adjacent and hypotenuse? Cosine. So I would say cosine of 35 degrees is equal to what's adjacent? Z over hypotenuse, which is 20. What am I going to do to both sides? Multiply by 20. Always multiplying by that denominator. So Z is equal to 20, not 820, 20 cosine 35. and I get 16.4 what? Inches. Didn't leave enough room there for that. Do you notice anything interesting about these two? They're the same. Why?
Because it's the same triangle.
How is it the same
Well,
triangle?
it's the same, it's not the same triangle, it's a different triangle, but it's the same measurements.
Well, here's 20 inches and 20 feet, so inches and feet, but 20 and 20. Those angles aren't the same, though.
They're the same hypotenuse.
They're the same hypotenuse, but
No, it's sine and cosine.
I use sine and cosine, but the angles aren't the same. So why did I get the same answer?
Because it's the different angle.
How would I find this third angle?
You add 35 to 90 and then,
Don't all three angles equal 180?
minus 35.
So 180 minus 90 minus 35 means that other angle is 55 degrees. It is the same triangle. Kind of crazy, huh? All right. You try this guy. You try this guy. Am I using sine, cosine, or tangent? Cosine.
What?
That is a hypotenuse.
I was in the wrong column.
You following me so far? 14.1. And I always forget whether it's one apostrophe that's inches or feet or whatever. I'm just going to use the same notation that they do and give it one apostrophe. Is that what you got? Okay, keep going. Keep going on the last two. Is that what you got for that one?
Yes.
Those ones are quick. And is that what you got for that last one? Okay. Really quick, before I turn the page over to do the back side, where is my graphing calculator? Here it is. Okay, I want to show you something if you have a graphing calculator and you keep getting the wrong answer for some reason. Okay? When you turn on your graphing calculator, there is a button right here that says Mode. Click on your Mode button, and there is a spot, where is it? It's about 4 down, where you have the option of radians or degrees. If my calculator is in radian mode, it will not give me the right answer when I type in 40 degrees. So if you're in a graphing calculator and you are in radian mode there, you have to go and change that to degrees before you'll actually start calculating things correctly. Okay? The scientific ones, I believe, are standard in degrees, so you're fine. But just check that if you have a graphing calculator. Okay? All right, backside. Now we're getting to solve the triangle. What does it mean to solve the triangle? That means when a triangle is solved, that you know the length of all three sides and all three angles. Okay? So, here is all three angles, angle A, B, C. Notice they're all capital letters. And here are the three sides, little a, little b, little c. So, a couple of things that they don't tell me that I need to know. Angle C always has to be your right angle, so go ahead and label it as 90 degrees. And when you draw your triangle, I always draw mine the same direction just because it's habit and it gets easy. I'm going to label that right angle as angle C. The other two angles, doesn't matter which one you call A and which one you call B. I'm going to call this one A and this one B. I just usually go in order. And they're telling me little a is 7. Well, what side is little a? It's the side opposite big A. So that means this side right here is 7. Little c is 15. What side is that? That would be your hypotenuse. Okay? So let's say I wanted to find angle A first. If I wanted to find angle A first, using the two measurements that they've given me, 7 would be considered what? Opposite, adjacent, or hypotenuse? Opposite. 15 would be considered what? Hypotenuse. And what uses opposite over hypotenuse? So I'm going to say sine of A is equal to 7 over 15. Now, how do I find angle A?
Wouldn't it be the inverse sign?
Yep, I have to use my inverse sign, and I'm going to type in 7 over 15 because that's the sine ratio. That will give me my angle. So second sine of 7 over 15 gives me 27.8. And how am I going to label that? Degrees. So what did I just find? I just found angle A, 27.8 degrees. What do I know about all three sides of a triangle?
180.
Or all three angles. They equal 180. So I can find angle B pretty quick now, can't I? 180 minus 90 minus 27.8, 62.2 degrees. Okay, so far so good? I have one more thing to find.
Little b.
Little b. How do you think I can find little b? Pythagorean theorem. I could use trig if I wanted to, but I don't need to. I'm going to say 7 squared plus b squared equals 15 squared. What is 7 squared? 49 plus b squared equals, what's 15 squared? 225. Subtracting 49, I get b squared is equal to 176. How am I going to find what b is? Square root. So, the square root of 176 is 13.3. Do they give me inches, feet, something like that? So I'm just going to call it 13.3. Now, when you take the square root of something, aren't you supposed to take both the positive and the negative square root?
Yeah.
Why did I only take the positive square root?
Because there can't be a negative length.
Because I'm talking about the length of a side of a triangle. I can't have the side of a triangle that's a negative length. That just doesn't make sense. Length always has to be positive. So we disregard the negative side on that one. Okay? All right, so here's my next triangle. This one's drawn and labeled for me, so let's fill in the information I know. Do I know what angle A is?
No.
Not currently. Do I know what angle B is?
Yeah.
What is it?
54 degrees.
Do I know what angle C is?
Yeah.
What is it?
90 degrees.
Do I know what little a is?
No.
Little a would be opposite big A. I do know that one. Do I know little b?
No.
Do I know little c? Okay. What's the easiest thing to find first?
Angle A.
Angle A. How do I find that? Yep, 180 minus 90 minus 54 means angle A is 36 degrees. I'm pretty confident about that. Let's see. Let's say I want to find little b first. So that way I can use the Pythagorean theorem to find little c. So if I do little b first, using this angle, how is it related? Opposite, adjacent, or hypotenuse? Opposite. And this one is what? Adjacent. So what am I going to be using? Sine, cosine, or tangent? So tangent of 54 degrees is equal to little b over 8. How do I get little b by itself? Multiply by 8. So b is equal to 8 tangent 54, which is 11.0, or just 11. Does it have a label?
No.
Nope, so I'm just going to call it 11. And so how can I find c squared? Or c? Pythagorean theorem. Now, here's a quick question for you, though. What if I'm not 100% confident that I got b correct? If I'm not confident that I got b correct, I don't want to use b to find c. Because if it's wrong, then it's guaranteeing that c is going to be wrong also, right? So is there another way that I could find c that uses information that they gave me so I don't have to risk that?
Yeah.
Couldn't I call this, if this is little c, this is hypotenuse and adjacent, which is what? Cosine. So I could say cosine of 54 is equal to 8 over little c. This is about the same amount of work as the Pythagorean theorem. C cosine 54 equals 8. Divide by cosine 54. And let's see, c is equal to 8 divided by cosine 54, 13.6. Out of curiosity, is that the same thing we would have gotten had we used the Pythagorean theorem? 8 squared. 8 squared plus 11 squared is 185. Is the square root of 185 what I got? Yep. So I would have gotten the same thing. That gives me a little bit more confidence that now I know that B is correct. Okay. Okay. All right, last problem. There is a lot of stuff written down here. The actual problem itself is right there. Everything else is just like hints. Okay. So all of this is help for if you've forgotten how to multiply radicals or how to square them. We're going to rationalize a denominator. But something I want to show you first off is this funky symbol. This funky symbol is known as the Greek letter theta with a TH. I have to specify that because a lot of people try and pronounce it theta with an F. It's not theta with an F. It's theta with a TH. Okay. What theta is the most commonly used variable in trigonometry. Instead of saying x is the angle we don't know, they will always say theta is the angle we don't know. It is always used to represent an angle. So, they're telling me that I need to find the tangent of theta, or the tangent of this angle, if I know that the cosine of this angle is 2 radical 6 over 7. So here's what I'm going to look at. I'm going to draw a triangle. Okay, here's my right triangle. It doesn't matter which angle I call theta, as long as I don't label the right angle theta, because the right angle always has to be C. So I'm going to call this one theta. Now, if they're giving me the cosine, they are giving me the adjacent over the hypotenuse, correct? So let's label those two sides. What side is adjacent theta? The vertical one or the horizontal one? The vertical one. So they're saying this one is 2 rad 6. And the hypotenuse they're saying is 7. What do I need to know in order to find tangent? I need to know the opposite and the adjacent, right? So I know that tangent of theta is going to be equal to something over 2 radical 6, right? I just don't know what the opposite is to fill in there, right? How do I find the opposite? Can I use Pythagorean theorem? If I know 2 out of 3 sides, I can use Pythagorean theorem, can't I? So that would mean that 2 radical 6 squared plus, oh, I'll call this little b squared just for good measure, equals 7 squared, right? How do I square 2 radical 6? Put it in your calculator. Or 2 radical 6 times 2 radical 6. That's 4 radical 36, which is 4 times 6, which is 24. Now, you don't need to show all that work, but that's just the process of how it gets down to being 24. Plus b squared equals 49. If I subtract 24, I get b squared equals what? 25. So when I square root that, what does b equal?
5.
So the opposite is actually 5. So I can set up my tangent, right? So if cosine is 2 radical 6 over 7, tangent is 5 over 2 radical 26. I'm 90% done with the problem. There's one issue with that answer, and it has to do with the fact that in general, you are not allowed to leave a radical on the bottom of a fraction. Do you remember that at all? No. So how do I get a radical off the denominator? Well, let's look at what is causing the issue here. Everything is fine in that fraction except for that 6, right? So what I'm going to do is I'm going to multiply by radical 6 over radical 6. Now, Mrs. Franken, why? Don't we always have to do one thing to the right side, the same thing to the left side? Like if you're adding, don't you have to do it to both sides? If you're multiplying, don't you have to do it to both sides? How can I get away with only doing that to one side? Well, what is radical 6 over 6 equivalent to? 1. So am I actually adding anything to the problem? No. Not by multiplying by 1. So it's okay to do that to one side. If it wasn't 1, then yes, I have to do it to both sides. But if it's 1, then we're good. So let's see what this simplifies to. I have tan theta is equal to, what do I have on the top? 5 radical 6. And on the bottom, I have something kind of similar to up here. But 2 times, this would be a 1. 2 times 1 is 2 radical 36. What is radical 36? So on the bottom, I really have 2 times 6. So I think my final answer is tangent of theta equals 5 radical 6 over 12. So? That's my answer right there. Okay? So that's called rationalizing the denominator right there. You just multiply by that number over itself, and then do some simplifying, and the radical disappears off the bottom. Okay? Question? How did I get 36? Good question. 6 times 6. You can always multiply inside a radical with inside a radical. Your answer is inside a radical. You can multiply outside with outside. Same thing with reducing. This is something important also. When you have a fraction like this, you can reduce what's outside on top with what's outside on bottom. You can reduce what's inside a radical with what's inside a radical. You can't reduce something that's inside with something that's outside. Okay? In a radical, but not in a radical. You can't cancel that. Okay? All right, here comes your homework. Happy studying.